Thank you for coming to this session today, in person in here, and also people watching on the stream in the other hotels, and also even people in the future watching this online. Today, this talk is called Navigating the Journey of a Serverless Event-Driven Architecture. We have a jam-packed session, so I'm just going to dive straight into this. First of all, I have to introduce myself. My name is Dave Boyne. I'm a developer advocate here at AWS, and I primarily focus on serverless and event-driven architectures. Before joining AWS, I spent about 15 years working in enterprises and startups, and even took some time out to do open source full-time building event-driven tooling. And today it's my job here to navigate you through this journey of an event-driven architecture using serverless technology. And this is what we're going to be speaking about today. As I mentioned, we have a packed agenda. So first of all is, where do we get started when we build event-driven solutions? Where you think you should get started and where you probably should start. Next, in the middle of this talk, we're going to be talking about integration patterns, talking about messaging patterns, and talking about common pitfalls that you'll come across and how do you avoid them. And then finally, talking about operational maintenance. There's 3 years, 5 years, 10 years into the future, something we often overlooked as we build event-driven solutions. The resources to the whole deck, the deck itself, everything I speak about, you can find on that QR code. This QR code will be shown again at the end of the presentation, so don't worry if you don't get it now. And I just ask one thing of you all watching, and also watching on the stream, is just thinking about your use cases, your business and requirements, and thinking about how can event-driven architectures, or how can the topics we speak about today help you. So I want to start off by saying this, is that the adoption of event-driven architecture is growing, right? And you see this everywhere. You see it if you're in the community, that the word event-driven architecture keeps coming up. And it's interesting because event-driven architecture isn't anything new, right? You can go back, you can find white papers actually going back 40 years around event-driven solutions. So why is it that we have this adoption of EDA growing? It's because event-driven architectures are becoming more accessible to us, okay? And here are some of the AWS services that are making this possible. So hands up if you're using AWS Lambda in the room. Cool, so I'd say about 3/4 of the room. So AWS Lambda, the serverless compute, being able to do compute based on different runtimes, all triggered by events. Now, if we match this to API Gateway as an example, that event could be a HTTP event, right? Next door to Lambda, we have step functions. Any step functions users here? Cool, so I'd say about 1/3 of the room here. So step functions, being able to orchestrate business logic, being able to do orchestration, being able to visually see what is going on, again, triggered by events. Next door to that, we have Amazon EventBridge. EventBridge users in here? Yeah, cool, so I'd say half the room. So Amazon EventBridge is fully managed service, event bus with routing capabilities, transformation, going to different AWS targets, again, with events. And then DynamoDB, as we listen to DynamoDB streams, we can listen to inserts, updates, and deletes, and actually react to these things. Now, when we talk about event-driven architectures, the question is, well, what are event-driven architectures? If we started at the top, what would we see? And when you start to dive deeper into this, you'll come across 3 main words and terminology that comes up. You'll come across producers, you'll come across consumers, and maybe some kind of channel and some kind of broker in the middle here. Now, at a high level, yes, this is event-driven architectures. This is the core of event architectures. But what happens when we start to build with event-driven solutions? And in fact, the adoption of event-driven architecture is actually a journey that you will go on. You don't one day wake up and say, I have a producer and I have a consumer and now I'm event-driven. In fact, it's multiple patterns, it's multiple things, and again, it's this journey that we tend to go on. Now, if we were to visualize this journey, I'm a very visual person, this is what I would think it would look like. At the top here, we have these peaks, these promises that event architecture promises to give us. Decoupled architecture, this business agility that we can get, and also this evolutionary architecture that we are promised. And it is there, we can get it, it is there for the taking. But often you'll find common pitfalls as you go along, building this event architecture. You'll think about unclear boundaries and leaking information, lack of standards, lack of governance, lack of discoverability, understanding async versus sync behaviors. So this is what we're going to be speaking about in this talk, going through this journey. And the question is, when we start building event architectures, is where do we actually start? Where should we start? And equally, why do we even care about events in the first place? Now, there's a good analogy here I like to tell is events tell a story, okay? And tables tend to tell us the state right now. Example would be, when did I wake up this morning? So events, when did I wake up? What did I have for breakfast? Have I done a talk before this? How did I get here? Did I get a taxi? Or did I walk here? All this information just about me, about today, these are events. Now, equally, tables on the other side, we're talking about state. So if you were to query me, which sounds super weird, do not do that, but if you were to query me, I'm right here talking to people about event architectures and people on the stream. So again, practical example, let's talk about pizzas, pineapple on pizzas. Any pineapple on pizza fans? Yes, look at this. I found my family. So pineapple ordering app. So I open up the app and I get the state of all the pizzas, right? This is the state, this is information in tables. Now as I'm ordering the app, I'm adding pineapple on, I'm removing, I'm checking out, I'm not checking out. All this information are events. Every organization I've ever worked in are interested in events. And what you'll find out is that modern applications tend to have both events and state. Again, when we look into the benefits of event architectures, we see this loosely coupled systems, this agility, extensibility that you're promised. Before joining AWS, I was in a startup building event-driven solutions on AWS, in fact, and it was an agility that I've never seen over 15 years ever in the team that I was leading. So the big question is, many people have, is where should we start when we build event-driven solutions? And I've distilled it into two main places here. Number one is we just implement. We can take a shortcut across this mountain, right? We can start implementing. Number two is we understand behavior. And I want us to focus on this first, the implementation stage. What happens if we start to implement? So here we have value over time. As you build your event architectures, we start to implement. And what you'll notice, typically what happens is we get this bump in initial value, right? Maybe we're using EventBridge as an example, a fully managed service, and we have that bump in initial value, this producer and this consumer. Now, as time goes on, we add more producers and we have more consumers. But what you'll notice as time goes on in your event architectures is that value tends to plateau over time. Now, why is that? Well, let's map the complexity over time and see what happens. So what you'll notice with event architectures is that complexity can grow over time. We have the initial producers, that initial consumers, and then assumptions can be made. We have a lack of standards, lack of governance, lack of discoverability, as an example. Even unclear domains, what goes inside our events. Let's have a look exactly how this looks. So here's an architecture that I'll be referencing throughout this talk. Simple one, we have an order service, and we have downstream consumers. We have some kind of broker, some kind of event bus in the middle. We, as the order service team, have been tasked to raise an event. The order created event. An order has been created. So what we decide to do as a team is lean into AWS here to help us. So we're using EventBridge here as an example for those who not recognize the payload. Let's step into that. So we have the detail type. The order has been created, right? This is a mutable fact, mutable information. The order has been created. That's fine. Next, we have the source. Now, we're using the source as the domain. We are the order service. So what we're going to do is have myapp.orders here as an example. Now, down here is the most important part of your envelope of your message is the detail object in this example, right? This is entirely up to us. Now, what we decide to do is add the order ID and the user ID inside this event. Fine. That's great. So the downstream consumers are happy. They got an event. They got some information. Everyone's happy. Then 3 months down the line, we are tasked to do the order cancelled event. So we've done this before, so let's do it again. We create the order cancelled event. What we do in here, we add a reason. Why was the order cancelled? Because it was no longer needed. Now, as a consumer of this event, this may or not be interesting. It could be interesting because we could send a text message or an email to say that the order has been cancelled, it was no longer needed. Fine. The order has been cancelled, type TW. Does anyone know what type TW means? Put your hands up when you cancel an order. No one in the room, right? And I don't know what it means, I kind of made it up. But what I mean by that is it's so easy for us to add implementation details of our domains inside our events. As a consumer of this event, that type TW means nothing and is useless. So we move on, we have the user object. This is fine, but this time actually we've got an object. Previously we had the user ID in there, but we have the ID in here, that might be fine. But we have first name and last name. Is this sensitive information? Are we regulated? Can we share this information? Don't know, we continue. Consumers are happy. We're moving on with our life. We're building this event architecture. We have order updated event that comes along, and we continue this journey. In fact, more domains arise, and we have more events and more events coming into our event bus. And equally down here, on the blue team, they're actually sending commands with events. Please send an invoice email. So now we're getting into this weird territory of using events as commands. And typically what tends to happen as you're doing this system is unclear domain language is arising, unclear languages. And I'll tell you a story. I used to work in the life insurance startup, actually building on AWS, leading a team. Right, and we had this idea that a policy, a customer has a policy, a life insurance policy. So we modeled this policy in our development team as something a customer had. Right? We'd raise events, so we'd store all this information. Now, when we integrate with the insurer turns around and says, no, 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 no. The customer, we own the policy, the user so happens to be part of that. So we have some weird terminologies going on. And then the underwriter came along, and the person paying the bills actually says, hang on, no, 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 policy is something completely different. So we end up in this weird and wonderful world where, in fact, we end up with this, which is like this big ball of mud. This is terminology from domain-driven design here. But we have unclear domains, unclear structure, unclear intent and boundaries, and information leaking in our events. This quote is from Alberto. He's the author of Event Storming. And he says, it's the developer's misunderstanding, not the domain expert's knowledge, that gets released into production. Okay? I want to focus on that misunderstanding, that understanding part, because if we took a step back, right, and not do implementation first, what happens if we actually understand the domain first, understand the behavior first of our event-driven solution? So what do we mean by this? Well, we're understanding the behavior of the system. By doing that, we're collaborating with domain experts. We're collaborating with product owners, collaborating with even customers, or maybe CTOs or CEOs, or whoever else that might be. By collaborating, we can actually identify events within our organization. Okay? And when we identify events, we can identify boundaries, that domain information, and we can also identify language, common language that is used in our organization. So one way to do this is to use event storming. And has anyone used event storming before? Okay, so about 5 people. So event storming is a great method, a way to actually start with a new system or an existing system to understand the behavior of the system, okay? So you get post-it notes, you get domain experts in the room, and we start to map events over a timeline. This happens, then this happens, and this happens. Once we identify events, we can identify boundaries and aggregates, right? It's a very good way to visually represent, excuse me, a system. So here's an example of what I mean. This is a car parking system that I did last year. And for example, you drive up in the car and you press a button and you get a ticket. Now we can model this using event storming. As you see up here, we have the ticket machine. That's the system we're representing here in pink. And we have a command. Please create me a ticket. Commands can be rejected, and we're going to be talking about that in a minute. But then equally, as the system does stuff, we raise events. We group these in boundaries, and we have a timeline across the bottom. Now, the great thing about event storming is that I can guarantee no one's probably seen this slide in this room or watching on the stream. But I can guarantee a lot of people seeing this can understand the flow of the system, understand where the events are, and we can discuss the events and the payloads in this particular way. So event storming is a great way to actually visually see what's happening, understanding that domain, because once you understand this, you can then go on to implementing. Okay? And when we start to implement, what do we mean and what should we know? What should we think about? And the important part of event architectures really is understanding different types of messages. Okay? So the first one is we have commands, queries, and also events. Your architecture will have probably all of these. So a command, for example, can represent an intent, perform an action. A command can be rejected. Okay? Please order that pizza. No, we have no pizzas left. This is a command, it's rejected. Once we order that pizza, as an example, the order service here can raise an event to notify everyone in the system something has happened, that the order has been created. Now, a top tip, I would say, if you're raising events also is to raise events without consumers. Because this is the whole point about the event-driven architectures is we want that extensibility. So when you think you should raise a domain or business event, it might be a good time to do that. And equally, you also have queries, querying for information. Get me the pizzas, for example, on the app. Now, as you're going through your journey, this serverless event architecture journey, you're going to be coming across various different messaging patterns. Okay, you're going to be coming across point-to-point communication, publish, subscribe. You'll be coming across event streaming. Equally, you'll be probably looking at how integration patterns can help you avoid these common mistakes and nuances as you navigate. And also, there'll be coupling traps that you'll fall into. I can probably almost guarantee that. And equally, to how domain-driven design itself can actually help us build our event solutions. And this is what we're going to be talking about now. Let's dive into some of these in a bit deeper. So the first thing is this. We are tasked, we are the order service, and we are tasked to integrate with this new fulfillment service. We get an API request, that's great, and we can call this thing directly. Fine. That's one way of doing it. But when we start to think about these architectural trade-offs, start to think about, does the order service know too much? Maybe, maybe not. What about processing at the same rate? What happens if the order service is taking on a sale, for example, Black Friday as an example? We get all this traffic and we're bombarding the fulfillment service with these events, this information. So what happens about failures? Well, if the fulfillment service fails, the order service fails, and then the user that made that request might also get a bad experience. So again, what do we do? What do we look at to help here? Well, we can introduce some kind of point-to-point channels. We can introduce queues as an example. So what we can do here is put some information on a queue. We can put these messages on a queue. Now, why would we want to consider this? Is because the order service no longer needs to know about the downstream consumer, about that fulfillment service. We are decoupled. And then equally, we're processing at a desired rate because the fulfillment service here can pull messages off of the queue. And that is the key part. Also, isolated failures. Okay, so if the fulfillment service fails, we can set up things like dead letter queues to actually catch the messages rather than letting them drop. And in this way, the user probably won't get a bad experience because these errors are handled in the back end. So again, what we're talking about here is point-to-point communication and messaging. So this decreases the coupling, but also that consumers pull messages from the queue to process them. As consumers pull these messages to process them, we can also scale the consumers. We can have multiple consumers pulling messages off. And a visualization I like to think about this is when I go Christmas shopping, right? I'm going to leave reInvent, go home, back to the UK, and go Christmas shopping for my kids. And as I'm pulling stuff into the basket, I see a queue, right, a shopping queue. And Brits, is any other Brits in here? Yes, we love a queue, right? We love queuing. We see people lining up, we join them. So as I'm standing there queuing up, always is like 1 or 2 cashiers, and it's about half an hour wait time in this queue. So why am I talking about this? Is because if you're lucky enough, more cashiers will come along and process that queue faster. That's exactly what we're talking about when we're talking about queuing here and multiple receivers pulling information off. Now, if we link this back to a serverless event architectures and link this back to your journey, you'll probably be using something like Amazon SQS, which is one of the first services we actually released, and it's a fully managed message queue. Is anyone using SQS here? Cool, a lot of people. So scales to almost infinitely and supports things like dead letter queues, so we can, and also FIFO queues, so we can process things in order if that's a requirement for you. So point-to-point messaging will be part of this journey. So what's next? What other things will you lean into? This time we're the order service team and we've been tasked to notify downstream consumers something has happened. Now again, we can do this, we can integrate with them and just notify them. Now again, the trade-offs that we're thinking here, does the order service know too much? Probably yes. What about failures? If that fulfillment service failed, that middle one, and the top one succeeded, what's the state of the architecture? What's the state of the data now? And equally down here, we've got duplication of effort as we integrate things over time. Now, of course, what we can do here is lean into pub-sub, publish-subscribe patterns, actually notifying downstream consumers that something has happened. On the left, the producer has no idea who is consuming. They just release and push an event onto the event broker. Now here, what we're talking about, of course, as I mentioned, is pub-sub. So it's a push model. And with many brokers, we can actually do things like routing or enriching, as an example. So as you can see here, half the receivers might be interested in blue T-shirts, as an example, and half may be interested in purple, as another example. So publish-subscribe is another pattern that you'll probably use. And to help with that, as we lean into serverless architectures to help with this, Amazon Event Bridge is a fantastic way of doing this. Lowering that barrier to event-driven architectures, we have over 28 different AWS targets that you can reach. And one of the fastest growing features of Event Bridge actually is API destinations. So what we can also do is reach out to third parties with our events and notify them of things happening with API destinations. And equally, as you go on into this journey, you'll come across event streaming. So this is thinking about unbounded data, thinking about clickstream information as an example, or likes on a video streaming application as an example. By itself, this is just loads of events, loads of information coming in. Not that valuable, could be not that valuable to our organization. So what can we do here as an example? So streaming use cases might look like something like this. This is Kafka, data streaming platform, right? Open source Apache Kafka. So we get this clickstream information and we get consumer. This consumer aggregates this information and then downstream we create a new topic. This topic so happens to be a domain event, something we are interested in, a discrete event. What we can do here actually is use EventBridge connector here, which was released this year, to connect this directly into AWS, connect this directly into our event bus, where we can go out. So this is kind of best of both worlds, where we have streaming and we also have discrete events. Equally, talking about event streaming, is we have this, which is change data capture, right? As you go along your journey, you'll come across these. Listening to changes in a database, super powerful. Deletes, inserts, updates. DynamoDB Streams handles this. It can give you this information. So you'll probably lean into some of these tools and some of these messaging patterns as you go along your journey. So we have point-to-point, we have pub-sub, we have streaming, and event storming as a way to kind of visualize these events. Now, as you go along this architecture, there are common questions and common pitfalls you will probably fall into. And let's have a look at some of these now. The first one is this, very important one. What goes inside our events, right? On the left here, we are raising the order placed event. And the consumer comes along and says, thank you very much. This information is a bit sparse, but we'll get what we want. This leads and can lead to this, which is called, I like to think of it as like accidental coupling with callbacks, okay? I remember when I was working for this insurance company, I remember coming in one day with my tea in my hand, because, yeah, I love tea, and coming in one day into the office, and the engineer comes running up to me and says, Dave, we've gone viral, right? And this was fantastic, because this was a startup that I was working at. Dave, we've gone viral, you should see our graphs. Okay, so as I'm walking through the office, I see the graphs, I see these ticks going up in the top right, and I'm feeling good about myself. And as I kind of sit with him when we're diving deeper into everything else, in fact, we haven't gone viral. All that's happened is we had more consumers of our events. Why has this happened? Because the consumers come along and say, thank you very much, I'm going to now go and fetch the information I want. Where does it get that from? Maybe the producer, maybe somewhere else. It's an interesting pattern because by design, we are decoupled because we're using events, but the schema of the event itself has led to this coupling. So what options do we have here? Well, we can use one of the enterprise integration patterns called the content enricher pattern. So what this allows us to do is have the sender still use sparse events, sparse schemas. Now, you may want to do this because the more things you have in your schema, the more things you've got to manage and version, as an example. So you can still keep that small. And the consumer over here is saying, please give me more information. So what can we do? We can introduce something in the middle called the enricher. So what the enricher does is get this information, enrich it, and then pass that on to the downstream consumer. And let's have a look at how we may do this in a serverless example. So is anyone using event bridge pipes? Cool, one or two people, I think. So event bridge pipes, we spoke about point-to-point communication earlier. Event bridge pipes is a point-to-point service. An example being, here on the left we have the source, and on the right we have the target. Very popular patterns would be things like DynamoDB streams directly into EventBridge, or step functions. Other popular patterns could be kinesis streams, streams of information into other streams, again, managed for us with pipes. Now, there are two cool features about pipes which I absolutely love. Number one of them is filtering. So what we can do is filter information. We are only interested in this particular information in this stream, or DynamoDB stream, or SQS queue. We can filter it and then get that onto downstream consumers. We only pay for the ones that are filtered and not the others. And then equally here, we can enrich and transform. Okay? So we can enrich using Lambda. We can enrich using express workflows with step functions or API gateways. We can even enrich using API destinations going out to third parties and enriching information before it reaches downstream consumers. So a great way here, another way of just managing messages between producer and consumer and enriching them. So the next question is this: sensitive data inside of events. So earlier we had the first name and last name inside our event. Maybe we're regulated and we can't do this. So here we're placing the order placed event, and the consumer turns around and says, this information is sensitive. So what can we do about this? Well, we could do something like encryption patterns, right? In fact, we can get the whole object, this whole detailed object, which is, remember, this is entirely up to us, we can encrypt the whole thing and give that to downstream consumers. This is a valid pattern, this could work. But the thing is about doing this is we lose the ability to do event bridge filtering, as an example. Remember going from blue to purple. So what can we do here? Well, we can choose which properties we want to encrypt. So as you can see here, the customer's name, address, and credit card are all encrypted, and we leave the rest unencrypted. This allows us to get the both of best worlds. So let's have a look at an example, a serverless example of how we could do this. So here on the left, we have a producer. We have a shared key. We're using AWS KMS here to do the encryption. So we have a key. And then what we decide to do is, as the producer, is encrypt some properties of our event. Now we give this to EventBridge, and this encrypted is encrypted at rest. Give this to EventBridge, and we create a rule on the bus to a downstream consumer. The downstream consumer gets the information that they need, and they use the shared key to unencrypt that information. Now, as downstream consumers come and go, because this is the whole point of event architectures, is they will come and go, you can only decrypt it if you have the shared key. So, of course, in this example, the producer may own that key and may choose who can decrypt that. So again, some trade-offs to consider here, some things to think about, but there are ways in which we can also encrypt messages as you go on your journey of your event architectures. The next problem that you may face is this one, which is processing large messages in your event architecture. PDF documents or huge JSON files that the services have messages limits. Example, EventBridge having 256 kilobytes. So again, how can we get around this? What patterns are out there to help us? And one of the patterns you'll come across is this, which is the claim check pattern. This is another enterprise integration pattern. So what happens here, an example, we have Lambda as the producer, doing some compute, and then we decide to raise an event. This time, before it raises the event, we store information inside of S3. We store that payload inside of S3. And we have that key back to the bucket, that reference, and we can push this onto the bus. Now, the consumer in this example would be step functions. Before it does anything, goes to get that information from S3. Examples here could be a pre-signed URL from S3 with a TTL of 2 hours or 2 days if you wanted to, or maybe just a path directly to the folder, to the file in the S3 bucket, right? But again, these are things and trade-offs to consider because now the consumer needs access to the shared bucket. We need to create a bucket to do this. So again, things to think about, but these are patterns that can help you along your journey. The next thing I want to talk about actually is one thing I'm super excited about, which is like integration time between systems. I can't tell you the amount of times I've integrated with APIs, with different services over the years, right? Integrating A, integrating B, using different APIs and credentials and managing all this myself. But what happens if we actually lean into streaming, lean into events to handle this communication for us? And this is exactly what we can start to do. We can actually have our organization, our AWS account as an example. We can have a broker which other organizations can actually use and put messages into. As you can see here, we've got organization 1 on the left producing messages that the organization 2 can consume. And again, back and forward using asynchronous processing. Here's a quote from James Arquin. He's the author of a book called Flow Architectures. And it's a book I recommend. It talks about the future of event streaming between cross-organizational structures. And I watched a podcast of his recently, and he says this, which is, lowering the cost of integration creates an explosion of new integrations and experimentation. And I thought, James has hit the nail on the head here with event-driven architectures. For me, this is what event-driven architectures is all about. It's about lowering that cost of integration so we can explore innovation within our organization, okay? And I want to show you an example of what I mean. Has anyone seen serverless video around reInvent this week? Call a few people. So serverless video is an application that I've spent the last couple of months building with the serverless DA team here at AWS. It's a video streaming application built entirely on serverless architectures, and it's open source. You can dive into this yourself if you're interested. What this allows you to do is actually broadcast from your phone to anyone watching. People watching can click on emojis, and we process that back to the users. Once they finish the broadcast, we do MP4 processing using step functions, event bridge, using recognition, using Bedrock, and all sorts of things. And this is what that architecture would look like, and does look like. So here on the left, we use Amplified to host the front-end application. And then we have APIs into the application. Now, we spoke earlier about commands and queries. So we have commands coming into the architecture and queries. So please give me all the videos that have been broadcasted at reInvent. Please start a new broadcast. These are commands of the system. We have an event bus that we're using. We have microservices. We're using Event Bridge to communicate between these services, having that decoupled architecture. We're actually listening to first-party events. So AWS services themselves release events into your default event bus. Super powerful. So an example would be we used Amazon IVS, which is the same broadcasting technology that Twitch uses. So we use that, and IVS are now publishing events into our event bus that we can consume. When the broadcast started, when did it end? Is it healthy? Now, the reason why I want to talk about this is the plugins extensions that we built. We wanted to go to other Amazonians at AWS and say, we're launching this thing at reInvent. We want you to build plugins. You have an event, and you have an MP4 file. What can you do? Document in the event. Within 2 days, our first plugin come through. Using Bedrock as an example to generate titles, to generate descriptions and tags. We get the transcription of the video, and we chuck it to the model to create them titles and tags. Other examples were next plugins coming doing like moderation on the video using recognition, right? That MP4 file, and then telling us if the video is valid or not. And we had leaderboard plugins and roll-up plugins and all sorts of things. This is all, again, open source. You can dive into this. But what I'm trying to say here is that we lowered the barrier to entry with using events, using documentation and schemas, and we had this innovation within this app. And this is where event-driven architectures can help. Here's another example where you see bi-directional events between organizations that we can do using Event Bridge and using step functions. An example, so this week we launched Stripe integrations directly into Event Bridge. Event Bridge supports over 40 different SaaS integrations that you can connect to. What this means is organizations can fire events directly into your event bus. There is no code there we have to manage. We can listen to these events. When the events come in, we can create rules and targets. Here is an example. We have a step functions workflow. Let's talk about example. When Stripe event comes in, we want to award customers if they have purchased 10 products over the last year. Well, we can orchestrate this workflow easily within step functions. Now, how do we go back out to Stripe? Well, interestingly, step functions released a new feature this week about HTTPS integrations directly with step functions. So what we can actually do is talk directly to Stripe, again, using step functions. So what we've achieved here is events coming in from the left, and that also going out to the right here, again, that cross-organizational boundaries of information. So I'm super passionate about this because I think as we go into event architectures in the future, there's going to be much more of this stuff happening about streams of information and sharing events and connecting to streams and events through organizational structures. So the next thing you'll see here, as you build your event architectures, you're going on your journey, you have loads of events, loads of consumers. And you have this. We mentioned a bit of this earlier about coupling through contracts. Okay, this is often overlooked. We are raising the order placed event. Thank you, we will consume it as it is. By doing this, by consuming a message or event as it is, you are a conformist by default. Okay? What do I mean by this? So an example, this is bounded context mapping. So now we're leading into domain-driven design and understanding how practices there can help us build event-driven solutions. So a conformist is something where we have an event. We consume an event as it is. An example of this would be the order service. The order has been placed. We are the fulfillment service. Thank you very much. We have all this information. We consume it. In fact, we have this model, this order model, just all over the code base because we consume it as it is, the fulfillment service. This may or may not be a problem, but an example would be what happens if the order service decides to change the schema, change the payload, then this fulfillment service would just break. So what other patterns are there out there to help us mitigate against that risk? Well, we could do something like anti-corruption layers, right? We can say, well, thank you for the event. We are the fulfillment service. The first thing we're going to do is change it into a model, into a language that we understand as a service. We have that protection around our service, okay? Anti-corruption layers, a different way of handling this. Equally, the opposite. So we can push back onto the producer and say, no, 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 no. We agreed a contract. We agreed a public contract in this organization. You are going to do the mapping, and we can fully understand that, okay? Different patterns depending on different circumstances. Now, the interesting thing here is with these bounded context mappings is actually understanding the level of communication that is required for each one, okay? Example here would be the conformist. Requires a very high level of communication because if the producer is changing contracts and they may break schemas, they've got to talk to the consumers, okay? There is this communication that is constantly required. Now, again, this might make sense, and we're going to speak about this in a second. But equally, on the other side of that, the less communication would be open host service. We had that initial communication. We agreed on a standard, right? But now, once the standard has been established, it's less communication that is required. So again, thinking about these. And I highly recommend, there are loads more, by the way. This is all open source. Highly recommend having a look at the context map cheat sheet. Just being aware of how am I consuming my events in my event architectures? How am I going to be coupled by this contract, and how is that going to affect our service? And here's Vladik. He's the author of Learning Domain-Driven Design, a fantastic book if you're interested in that. And he's writing a new book at the moment called Balancing Coupling in Software Design. And I watched one of his talks this year in Berlin, and I remember seeing this, which he says, the cost of change is proportional to the distance between components. Okay? And this is super important when we're thinking about, and we bring this back to event-driven architectures. Thinking about the distance of components. So what we're talking about here is private and public information. Now, I'll give you an example. We are the order service. Everyone in this room, the order service is very successful, lots of people. We decide to have an AWS account for this service. We're using EventBridge as an example to communicate between maybe little microservices inside of this service that we have. Now, because we are the order service, we can raise private domain events, right, using this technology. What do I mean by this? Well, if I add type TW on the event that we discussed earlier, this may not be a problem because everyone in this service understands the implementation details of that service, okay? Private information. This is completely different to public events, events we use to communicate outside the boundaries. Examples, order service, talking to payment domains here. That type TW no longer makes sense. That implementation detail no longer makes sense. Okay, we're using the same technology under the hood. We may be using SQS, EventBridge as an example. It's all around contracts. It's all about domains. It's all about boundaries of information. And again, understanding that coupling, understanding that distance, again, can really help you as you build event architectures, as you go on that journey, again, just thinking about these nuances and the trade-offs that you will be making. And here I just want to finish this section by saying that event architectures, we spoke earlier about consumers and producers and channels. What does it really mean? And to me, it means that event architectures really is a collection of patterns. Okay? And the more patterns that you explore, the more it will help you as you go along your journey. And in fact, domain-driven design can really complement your event architectures. So if you're not looking into domain-driven design, I recommend having a look and understanding how that can help you as you build your serverless EDA apps. And finally, the last section of this talk, I want to talk about this, which is operation and maintenance. So think about, so we've got queues, we've got SQS, we've got EventBridge. Using Event Stormer, we've got patterns, we've got contracts, we've got all these things going on. But how do we make sure we have this excellence, this operational maintenance in 3 years' time, 5 years' time, 10 years' time? So back to this again. So we have, as we build event-driven architectures, we have this high agility, low complexity that we're promised. In fact, when you start out, you will probably experience this. And as time goes on, if you're really unlucky, you might end up down in number 3, where you have high complexity and that low agility as time goes on. And I started to ask myself, why is this? Why does this happen within the community as we build event-driven solutions? And there's this terminology that keeps coming up over and over again, which is this. Hands up if you've ever seen this before. Or a few people. That producers should not know about consumers, okay? You were told this when you build event-driven architectures, that producers should not know about consumers. We're decoupled by nature. Here's our example of event-driven architecture app again. Back to this. As time goes on, we add more consumers. This is the whole point. We've got this evolutionary architecture. Consumers are coming, consumers are going. And as time goes on, in fact, we have more AWS accounts. Okay? We have more producers, more event buses, more consumers, and this thing grows over time. This is the whole essence of event architectures, as it allows us to do this. Now, as you do this, common questions will start to come up. Example 1 here. What events do we have? So new people join the company, people have left, people have done this before. What events do we have? And if you can find these events, the next question is, well, what's the payload of the event? Okay? I'm tasked to do a new email service as an example. I know you're creating an event, but where can I find it? What does it look like? Equally, I am tasked to change an event, but who is consuming this? Am I about to break an entire system? I don't know. It's interesting if we take a step back here that producers, yes, producers should not know about consumers. That is true. At a technical level, producers are decoupled away from the consumers, but that does not mean we can skip governance, standards, discoverability, okay? And if we talk about this, there's 3 sections of this maintenance, really. One is standards and discoverability, and then communication. So let's dive into more of these in detail. So first of all, we have standards. So thinking about your events, you're on your journey, you've got 50 events, 100 events, thousands of events. Every event is different, yes, that's fine. But the question is, what standards could we put inside our events? Okay, examples being, what about a correlation ID between all your events in your organization? Might be useful. What about a custom timestamp in your events? And I recommend doing this with EventBridge, by the way, because EventBridge owned the timestamp in that payload, so custom timestamps. Or maybe you could put the domain of the event in there, or maybe some documentation URLs, whatever it is. What is the standard of your payloads? Can really be useful. An example could be the orders domain. We know that by using the metadata inside the event. And what we can do is create an EventBridge rule one day and say, actually, I'm interested in listening or seeing some of these events within this domain. Now I can do that because we start to have standards. The next thing here, too, is about thinking about event-first thinking. Okay? So I'll give an example. When we build APIs within systems, within our architectures, we treat APIs, we nurture them, we love them. We've been building APIs as a community for many, many years. We have specifications for APIs. We discuss like REST, and we discuss verbs and versioning and all sorts of things. Introducing APIs in companies actually can be quite difficult. But when we introduce events, it's a different story, right? And that story tends to be, we have requirements, and we design it, and then we implement it. Now, event-first thinking, what we really need to start doing is more of this, is yes, we can identify, yes, we can define, then implement, but you've got to make sure you go back. because your events will evolve, your business evolves, your architecture evolves, your schemas will evolve, and you have to make sure they're kind of still relevant. And how do you do that? And I've got a talk here, there's a whole section on this. I've got a talk here if you're interested, a 40-minute section to dive deeper into that whole topic. But event first thinking, treating events as first-class citizens is really important. The next one we have here is discoverability. Okay, how do we find events? What's in the structure? What's in the payloads? So here we have schema registry. So I'm a super geek, by the way, when it comes to schemas. I think they're super important, often overlooked. And EventBridge actually have an awesome feature which is called the schema discovery. So if you're firing events into EventBridge, what you can do is turn on schema discovery on your event bus, and EventBridge will manage and version the schemas for you. What it will do, in fact, is give you JSON draft 4 versions or open API versions of your events. And then what you can do then is download code bindings. You can download Java or .NET or TypeScript code bindings that you can use within your code, again, to match these events. An awesome feature of the service that might be helpful. Next thing I want to shout out here is async API. Has anyone heard of this? Awesome, yeah, so I'd say about 10 people here. So I used to work on this full time, actually, before joining AWS. I was part of the team here. Async API is a specification, open source specification that allows you to document your event-driven architectures. Okay? Documentation of event-driven architectures is really, there's a huge gap at the moment around this area. What async API allows you to do is actually document channels, document producers and consumers. It's not tied to any technology. It has many different bindings, Kafka, SNS, SQS as an example. So you can use async API to actually do this. Now, the great thing about async API specifications in general is once you have a standard, you start to build tools and tooling around that. So they have hundreds of different tools. And I recommend if you're looking at ways of discovering and documenting, I really recommend checking this project out. And then finally, on this section, I just wanted to shout out, probably a shameless plug here, but Event Catalog. Has anyone heard of Event Catalog? Also a few people. So this is a project that I created a couple of years ago because I saw this huge gap in discoverability around event-driven architectures. And the only reason I'm sharing this with you today is because it's actually growing in growth and really helping people document their event architectures. You can use, this gives you a static website that you can run anywhere and allows you to visualize and 3D visualize your producers, your consumers, and all it is powered by Markdown and MDX components. So again, just another way to get people in your organization access to events, consumers, producers. So again, if you're interested in that, it has plugin support for async API and EventBridge, and again, you could write your own plugins there. So again, just something there that might be able to help you out. And then finally here we have communication, okay? It's actually embracing the ubiquitous language, embracing this language that we have within our domains. As you can see here, we have the order domain and the invoice domain. Both of them have an orders model within them, but this orders model would be completely different between domains. And that's okay. It's okay to embrace that different languages that we can use within domains, that ubiquitous language. And understanding that can really help you, again, build your event architectures, understand your boundaries, understand the language in which you use within your domains, and again, mapping that back to events and how bounded context mappings here can help. And with all of that, hopefully this helps you stay away from that number 3 as time goes on, 3 years or 5 years, and just keep in that number 1 that event architectures can give you and provide you. Again, I've seen this firsthand. I've seen many customers have high agility and that low complexity as they build event-driven solutions. But it's really up to you to manage these nuances and things as time goes on. So with that, I just want to summarize this talk. We spoke about at the start that event-driven architecture really is a journey that we go on. We don't one day wake up and say, we got a producer and we got a consumer and now we're event-driven. So in fact, there's much more to it than that. When we start to visualize that event-driven architecture, you'll see these pros at the top here, which is like business agility, decoupled architectures, evolutionary architectures that they can provide. But then equally down here, we have the common pitfalls, and there are ways in which we can avoid these. We spoke about initial design. Why do we care about events? Well, events tell a story. Organizations are very interested in events. We spoke about behavior first rather than implementing first, and how event storming itself can help you paint that picture within your organizations. Then we talked about implementation. We spoke about commands versus events. We looked at messaging patterns, streams, point-to-point. We looked at pub-sub patterns on AWS to help you. And there are also integration patterns like enriching on context mapping with domain-driven design, again, can help you avoid some of these pitfalls that people often see. And then finally, we spoke about operational and maintenance. Okay? Spoke about standards. What goes inside your events? What do you want to standardize within your organization? Discoverability. How are people going to find your events? What's inside the payloads? If you think about that now, that can help your future selves. Communication, and again, reducing that complexity, move away from that number 3 into that number 1, and it is possible, but you need to start thinking about that today. In this talk, we talk about serverless services that can help you do this. We spoke about SQS, this fully managed message queue. We spoke about Amazon Event Bridge doing pub-sub patterns using filtering or transformations over 28 different targets. Also, API destinations, a huge feature that I love. Amazon DynamoDB streams, listening to changes within our database, change data capture patterns, how can that help us? And equally here, we've got Event Bridge pipes, as point-to-point managed service, doing enriching and filtering. Could that help you on your journey? If you're interested in more serverless learning, we have this free serverless badge that you can take, or take this back to your colleagues, so you can do this online in your own time, to dive deeper into some serverless stuff there. And then finally, I just wanted to share this resource with you at the end, like I said I would at the start. Everything I spoke about is in this resource pack. The deck, the slides are in there, and if you want to dive deeper, you can. To the side of it, I've created EDA visuals. Has anyone seen this before? Cool, nice, a few people. EDA visuals, so I spent a year just building event-driven architecture visuals. If you have 5 minutes, you've got 5 minutes to learn something about event-driven solutions. So these are all free, all online in that resource pack. You can download them all offline if you want to read them. But again, people seem to love visual ways of learning, so you can do that. And with that, I just want to say thank you so much for turning up today and watching on the stream. If you enjoyed this session, if you've got any questions, feel free. I'll be in the hallway track there. And if you like this session, please rate it a 5, and thank you very much.